Hello students, welcome back to Gate Electronics Guruji classes. So in the last video we discussed three indeterminate forms, and in this video we are going to discuss the last four indeterminate forms, and this will be the last theory video on limit. And after this video I think I will make one or two videos where I will solve only problems based on the concept of limit that might come in GATE exam. So let us come to the fourth indeterminate form. The fourth indeterminate form was infinite minus infinite form. So let us try to understand. Suppose we have a function hx such that hx is equal to f of x minus g of x. And suppose you want to check or you want to evaluate the limit of hx at x equal to a. So you want to evaluate the existence of limit of hx at x equal to a. So limit of hx at x tends to a is same as limit extending to a fx minus gx, right? That's what I have said. I said that suppose we have a function hx such that hx equal to fx minus gx. So clearly the limiting value of hx when x tends to a should be equal to limit of fx minus gx when x tends to a, because hx is fx minus gx. Now suppose we have a case such that limit of fx as x tends to a is equal to infinite, and limit of gx as x tends to a is equal to infinite. Okay, in that case this limit will said to be present in infinite minus infinite form, because see, this fx is tending towards infinite as said here. Similarly this gx is also tending towards infinite, because limit of gx when x tends to equal to infinite. So when these two conditions are satisfied, that is limit of fx when x tends to equal to infinite and limit of gx when x tends to equal to infinite, then I will have an infinite minus infinite form. So I hope that you understand that what is meant by infinite minus infinite form. Now I will take a problem of this case to show how to tackle this kind of form. Actually, there is no generalized method by which we can solve this particular form, infinite minus infinite form. So we will take one problem, or we will try to show how to evaluate the limit when we have an infinite minus infinite form. But again I am saying there is no mechanical method that you can follow to solve this infinite minus infinite form. Clear? Suppose you have a problem, say you have to find out the limit of the function root over of x square minus x plus 1, say plus x plus 1 minus x as x tends to infinity. Observe, when x is tending to infinity, clearly x square plus x plus 1, this sum will tend to infinity. So if x square plus x plus 1 tends to infinity, then clearly square root of x square plus x plus 1 will also tend towards infinity, and clearly this x is also tending towards infinity, because x is tending towards infinity. So clearly we have an infinite minus infinite form in this case. Now I have already said that there is no generalized rule by which you can tackle this kind of form, that is infinite minus infinite form. This will the way you have to solve, you have to tackle this infinite minus infinite form will actually vary from one problem to another. So I will teach you how to solve this particular problem, and if you find any problem while solving this kind of form, infinite minus infinite form, then please give me the problem in the comment section. I will definitely solve it for you. So what we can do it here, we have to rationalize this. So if we have root over x square plus x plus 1 minus x, if I want to rationalize this, I have to multiply this by the rationalizing factor. And what is the rationalizing factor of root over x square plus x plus 1 minus x? Nothing but the rationalizing factor of this is square root of x square plus x plus 1 plus x, right? The rationalizing factor of this is nothing but this minus sign will be changed to plus sign. And as we have multiplied this in the numerator, we also have to divide by this extra term in the denominator, right? Now let us multiply. If I multiply the numerator, if I multiply this function with this function, I will have x square plus x plus 1 minus x square divided by square root of x square plus x plus 1 plus x, right? This x square will cancel this x square, right? Now what you have to do is divide both the numerator and the denominator by x. See, after reaching this form, you can also observe that this is present in infinite by infinite form. So you can use L hospital rule, but that will be hectic. If you can make a very small observation, then this will be solved in a very easier way. Just divide the numerator and the denominator by x. So what you will have is, I am writing it here, limit extending towards infinity. I am dividing the numerator, that is x plus 1 by x. So I will have 1 plus 1 by x divided by, I will divide this denominator by x. So if I divide the denominator, I will have square root of x square plus x plus 1 divided by x plus 1. Okay. Now do one thing. From the square root of x square plus x plus 1, take out x outside the square root sign. So you will have limit extending to infinity. After this I am writing here, okay? Alright, after this I am writing here. So after this step I am doing this step here, okay? Okay. So limit extends to infinity, 1 plus 1 by x divided by, what I said, I have to take an x outside the square root sign. So I will have x times of 1 plus 1 by x plus 1 by x square divided by x, this x here, plus 1. See, what I have done is that I have taken an x from root over x square plus x plus 1 outside the square root sign. So I have this, clear? Now this x will cancel this x. Now observe, when x is tending to infinite, this 1 by x is tending to 0. This 1 by x is tending to 0 and this 1 by x square is also tending to 0. So if you simplify, you will have 1 plus 0, because when x is tending to infinite, 1 by x will tend to 0, divided by, when x is tending to infinite, this 1 by x and this 1 by x square will tend to 0. So I will have square root of 1 plus 0 plus 0 plus 1. So this is nothing but 1 divided by 2. So the final answer in this case is half, right? So I hope that you have understood that what's one possible way to tackle this infinite minus infinite form. But again I am saying, for infinite minus infinite form there is no mechanical method, there is no generalized method that you can follow to solve the problem. You have to look at the problem, and depending on the problem you have to decide how to evaluate the limit. See, like 0 by 0, infinite by infinite, 0 into infinite forms, in those three forms there was a standardized method by which we could solve it, that is L hospital rule. But in case of infinite minus infinite form, there is no such hard and fast rule. You have to look at the problem, you have to observe the problem and decide which particular method you are going to use, how to solve the problem. That's completely going to depend on the problem, okay? All right. Now come to the fifth one. The fifth one is 1 to the power infinite, right? Let me erase the board. The fifth indeterminate form is 1 to the power infinite indeterminate form. Okay. 1 to the power infinite. So let us try to understand. Suppose we have a function hx such that hx is equal to fx whole to the power g of x. Clear? And suppose suppose we want to evaluate the limit of hx at x equal to a. So we want to evaluate the limit of the function hx as x tends to a. So limit of hx as x tends to a is same as limit of fx whole to the power gx as x tends to a, right? Now observe. Suppose we have a case such that limit of extending towards a f of x is equal to 1 and limit of extending towards a g of x is equal to infinite. Suppose we have a case where the limit of fx as x tends to a equal to 1 and the limit of gx when x tends to equal to infinite. In that case, I will have a 1 to the power infinite form because this fx is tending towards 1 and this gx is tending towards infinity. So clearly I will have a 1 to the power infinite form. So I hope that you have understood what do we mean by an 1 to the power infinite form. Now the question is how to solve this kind of problem. There is a generalized formula that you can use to solve this kind of problem, which says this limit will be same as e to the power limit extending towards a fx minus 1 into g of x. This is the formula that you can use, which says that this limit will be same as e to the power limit extending towards a fx minus 1 into gx when these two conditions are simultaneously satisfied, right? That is, when we have an 1 to the power infinite form, then this limit can also be written like this. This can also be represented as exponential. This exponential is coming for this e. Exponential limit extending towards a fx minus 1 into g of x, right? You can use this formula. Now if you ask me that, sir, how to solve this one, that is limit extending towards a fx minus 1 into gx, you will see that always this fx minus 1 into gx will be present in a 0 into infinite form. You will always see that this fx minus 1 into gx will be always present in a 0 into infinite form. And you already know how to solve 0 into infinite kind of limits. So I hope that you can solve this from here, and obviously I will take a problem to explain what I said. See, the idea is that you simply have to keep this thing in mind, that is exponential limit extending towards a fx minus 1 into gx. Whenever you will have a 1 to the power infinite form, then you can directly write this, okay? So now let us take a problem of this case to have a better understanding of the concept. Suppose we have a problem, limit n tending to infinity 1 minus 1 by n whole to the power twice n. This actually, this problem came in GATE, I think 4 or 5 years before. Observe, in this case, when n is tending to infinite, this 1 by n is tending to 0, right? If n is tending to infinite, then 1 by n will tend to 0. If 1 by n tends to 0, that means 1 minus 1 by n will tend to 1, right? What I said? I said that when n is tending to infinite, clearly then 1 by n is tending to 0. So 1 minus 1 by n will tend to infinite, 1 minus 1 by n will tend to 1, right? So the base, that is 1 minus 1 by n, tends towards 1. And when n tends to infinite, then this twice n, that is this exponent or power, will tend to infinite. So clearly you observe that this is an 1 to the power infinite form. And what is the general formula? What I said, that if we have a function in the generalized case, what we said is that if I have a case like limit extending towards a, where fx to the power gx is an 1 to the power infinite form, in that case this limit will be same as exponential limit extending towards a fx minus 1 into g of x, right? If you compare this generalized form with this, you will see that here function was written in terms of x, but here it is in terms of n. But if you try to make an equivalence, you observe that fx is 1 minus 1 by n and gx in this case is nothing but twice n. So if I use this formula, in this case I am doing the second step for this here. I will have exponential limit n tending to infinite. See, this was equivalent to fx, this 1 minus 1 by n, and I have to subtract 1 from fx. So if I subtract 1 from 1 minus 1 by n, I will have 1 minus 1 by n minus 1 multiplied by gx. Here gx is equivalent to this twice n, so into twice n, right? So I will have exponential limit n tending to infinite minus 1 by n multiplied by twice n. This n will cancel this n, so you will finally have exponential minus 2 or e to the power minus 2. So this is the final answer. So I hope that you can understand how to solve or how to tackle the 1 to the power infinite form. Now let us come to the last two. I will explain the last two simultaneously. The last two indeterminate forms were 0 to the power 0 and infinite to the power 0, right? For both of them you can use a generalized way. Suppose, let us first explain what is 0 to the power 0 form. Suppose you have a function hx such that hx is equal to fx to the power gx, and suppose you want to evaluate the limit of hx when x tends to a. So limit of hx when x tends to a is same as nothing but limit of x tending towards a fx whole to the power g of x, right? Now if you have a case such that limit of fx as x tends to a is equal to 0 and limit of gx when x tends to a equal to 0, then we will have a 0 to the power 0 form. See, we have fx tending to 0 when x tends to a. We have gx tending to 0 when x tends to a. So clearly I will have a 0 to the power 0 form, right? And what is infinite to the power 0 form? I am erasing this, I am explaining here. So if you haven't noted it down, then please note it down. I can't wait for you to note, right? Okay. Now, if you have a case such that hx is given in the form of fx to the power gx, and if you have that limit of fx when x tends to a equal to infinite and limit of gx as x tends to a is equal to 0, then it will be present in an infinity to the power 0 form. See, fx is tending to infinite when x is tending to a, so this fx is tending to infinite, and gx is tending to 0 when x is tending to a, so this gx is tending to 0. So clearly we have an infinity to the power 0 form. So I hope you understand the idea of 0 to the power 0 and infinity to the power 0 form. Now I will teach how to tackle this kind of forms, that is 0 to the power 0 and infinity to the power 0. See, for both of these forms a generalized way can be used. I am explaining that way here, okay? So suppose you have a function given as hx equal to fx to the power gx, and suppose you have to find out the limit of this function at some point x equal to a, and you observe that the function is present in 0 to the power 0 or infinity to the power 0 form. So what you will do? See the steps. In the first step, you will take log on both sides. So you will have ln of hx, it's same as ln of fx to the power gx. And we know that ln of fx to the power gx is nothing but gx into ln time of fx. So from this step I can write ln of hx, it's same as gx into ln of f of x, right? So hx can be written as e to the power, hx can be written as e to the power gx into ln of fx, right? This can also be represented as hx is equal to exponential gx into ln of fx. This is simply another way of representing this e to the power gx into ln fx. Now see, what you had to do, you had to find out the limit of hx at some point x equal to a, or the function was either in 0 to the power 0 or infinity to the power 0 form. So now apply limit on both sides. So limit of hx when x tends to a will be same as exponential of limit x tending to a gx into ln of fx. So this is the generalized form that you can use, right? So whenever you will obtain a function hx such that hx is in the form of fx to the power gx, and if while finding the limit you see that the limit that this is present either in 0 to the power 0 or infinity to the power 0 form, first take the log on both sides, then represent hx in the form of hx equal to e to the power gx into ln fx, then apply limit on both the sides. Now you will always see that this limit, that is gx into ln of fx when x is tending towards a, this limit will always be present in 0 into infinite form. And you already know how to solve a limit if it is present in 0 into infinite form. So I hope that the concept is clear. Now let us solve a problem on this. Suppose we have a problem fx equal to x to the power 1 by x, and you have to find out the limit of fx when x is tending towards infinite. Clear? So you have to find out the limit of x to the power 1 by x when x is tending to infinite. Observe, when x is tending to infinite, this base is tending to infinite, and the power, that is 1 by x, is tending to 0, right? When x is tending to infinite, the base, that is x, is tending to infinite, and the exponent or the power, that is 1 by x, will tend to 0. So clearly this is present in infinite to the power 0 form. And in case of 0 to the power 0 or infinite to the power 0 form, I have already told you the steps. So I will repeat those steps here to find out the limit of x to the power 1 by x when x is tending to infinity. So what I am doing? You have fx equal to x to the power 1 by x, and your final aim is to find out the limiting value of fx when x is tending to infinite, and you observe that when x is tending to infinite, x to the power 1 by x is present in infinite to the power 0 form. First take ln on both the sides or log on both the sides. So you will have ln of fx equal to ln time of x to the power 1 by x, right? And ln of x to the power 1 by x can be written as 1 by x will come here, so it will be 1 by x into ln of x. The next step is I have to write fx in the form of exponential 1 by x into ln of x. I hope it is clear. If ln of fx is this, then fx is nothing but e to the power this. Exponential 1 by x ln x means e to the power 1 by x ln x, right? Now apply limit on both the sides. You have to find out the limit at x tends to infinity. So it will be same as exponential limit x tend to infinity ln x divided by x, right? And how to find out the limit of this? See, one thing I had said in the few minutes before, that this limit will always be present in 0 into infinite form. See, when x is tending to infinite, this 1 by x is tending to 0, and this ln of x is tending to infinite. So clearly this is present in a 0 into infinite form. Or you can also visualize this like this, like you have ln x by x. When x is tending to infinite, this ln x is tending to infinite, and the denominator x is also tending to infinite. So this can also be thought to be present in infinite by infinite form. When x is tending to infinite, the ln x is tending to infinite, the denominator x is tending to infinite. So you can say that this is present in infinite by infinite form. Whenever we have an infinite by infinite form, we use the L'Hospital rule. So if I differentiate the numerator with respect to x, I will have 1 by x, and if I differentiate the denominator with respect to x, I will have 1. So what I have is exponential limit x tends to infinity 1 by x. Now see, when x is tending to infinity, this 1 by x will tend towards 0. So we have exponential 0, right? Because when x is tending to infinite, this 1 by x is tending to 0, and exponential 0 is nothing but e to the power 0, which is equal to 1. So the answer is 1 here. So I hope that the concept is clear, and by this I complete the theory portion of limit. I will make one more video on limit where I will take few good problems from the concept of limit. So after limit, now we will start the concept of continuity, differentiability, mean value theorems, and the rest of the portions of the gate calculus part. So I will end this lecture here, and if you haven't still subscribed to my channel, then please do subscribe to my channel, because it's your likes, your comments, and your subscriptions that motivates me to make more and more videos for you. Thank you.